Good day. Welcome to this session. It is session 2 of Unit 1. Now, one thing that is very important as far as chemistry is concerned is being able to write the chemical formula of a compound. Now, you need this to be very successful when it comes to writing chemical formula and chemical equations. And that is what the unit is about. And so this session is taking a look at writing of chemical formula. So that's what basically we are going to do. Okay, so let's look at our objectives for this session. At the end of the session, you should be able to define a binary compound, define a ternary compound, and then you should be able to write the chemical formula for ionic compounds. Let's proceed. Okay, so if you are going to teach this concept, then these are what your students should know. They should have understanding of cations, anions, radicals, and valencies of atoms and ions. So these are what we did in the first session. Now we can proceed to look at our first objective, which is binary compounds. From the term binary. Now when we say a binary compound, we are referring to a compound that contains atoms of two different elements only. So in the whole of the compound, we only expect to count just two different elements, irrespective of the number of atoms present. For example, a compound like CO subscript 2, carbon dioxide or carbon dioxide, popularly called. There are only two different elements present. What are the elements? There is carbon and there is oxygen. We are not concerned about the number of atoms present. Our focus is two different elements or atoms of two different elements. So we can have plenty atoms present, but they should be of just two different elements. So other examples, we can have the copper 2 oxide, sodium chloride, hydrogen chloride, etc. This means that if we have a molecule like the hydrogen molecule, which is written as H subscript 2, that is not a binary compound. Why? Because there are only two atoms of just one element, which is hydrogen. The next one is ternary compounds, and they are compounds that contain atoms of three different elements. So here, once again, we want to see atoms of just three different elements. So for the examples that we have there, like the iron 2 nitrate, we only have iron, which is Fe, we have nitrogen, and we have oxygen. Those are the three different elements present. We are not interested in the number that is present. For instance, we have 6 atoms of oxygen, but that is not what our focus in as far as ternary compound is concerned. There are other examples like the tetraazosulfate, 6 acid, etc. Now we want to look at combination of ions and formulae writing. We want to write chemical formulae, and with that we are going to be combining ions. But what are the steps to follow? One is you should identify the ions in the compound from the IUPAC name. Remember, here we are writing a formula and we are writing it from a name, not a common name, but IUPAC name. And the first thing is to identify the ions present. By this, we mean you should split the compound into the cation and the anion. We are writing that of ions, ionic compound. So we should expect to see cations there. We should expect to see the anion there. You should split into these two ions. Second, write down the valencies of the ions. You remember valencies, the charge on the ion, but we are not including the sign, whether positive or negative. We are not including that. Then, if the valency of the cation is equal to the valency of the anion, then the two ions can combine to form the ionic compound. When we take a specific example, you will understand this point. Then, if the valency of the cation is not equal to that of the anion, then we need to do something. And what we are going to do is to multiply both ions by a factor so that they will be equal before they combine. Why? Because we are writing a neutral compound. So the number of positives should be equal to that of the negative, so that at the end they will cancel out for us to have a neutral compound. The number of each atom that combines with the other is written as a subscript against them. And if the number that combined is 1, we do not write any number. If it is a radical that is combining with another element, the radical is put in brackets and its number combining is written as subscript outside the bracket. So we can take a specific example. Let's say we want to write the formula of sodium oxide. So what do we have here? Now we need to split into ions, and with this we have the sodium ion and then we have the oxide ion. So Na plus and then O2 minus. So we have to do this. We have to split into the cations and anions. Now one thing is that usually for ionic compound, in the names, the cation is written first before the anion. So we have the Na written first, then the O2 minus. Next is to write down the valency. So like we have already indicated, here sodium has a charge of +1, so the valency is 1. Oxygen 2 minus, the valency is 2. Now what this means is that, you remember I said we are writing a neutral compound. At the end, negative should be equal to positive so that they will cancel out. But in this case, we have +1, we have -2. What do we do? It means we are going to need one more of the +1 so that we will now have 2 there to cancel the -2 at the oxygen side. And so we would be doing multiplication and we need a factor. But in order to make it simple and easy for you, it is good to just swap the valencies as the number you are going to use to multiply. So for this, it means that when we are going to write, then we are going to give 2 to the sodium ion and 1 to oxygen ion. So we need 2 of the sodium ions to balance that of the oxygen, because the sodium is +1, oxygen is 2 minus. Now if we get that factor, and in this case we are only cross multiplying, we are only giving the valency of sodium to oxygen and that of oxygen to sodium, then we are going to write each number as a subscript against its atom. But remember we said that in one of the steps that if it is 1, then we don't write. So when we gave the 2 of the oxygen to the sodium, then we have Na subscript 2. The oxygen will now have the 1, but because it is 1, we are not writing it. And so the formula is beautifully written as Na subscript 2, then O. Remember the O is capital O. Don't write a small o. It's mistakes that sometimes students do when it comes to writing chemical formulae. Another example is copper 2 oxide. Remember, copper does not have a fixed oxidation state, and so whenever the name is written, the oxidation state is indicated. In this case, we are dealing with copper 2. So once again, we split into the ions. We have Cu2 plus. In this case, it is even given there. The charge is given there. The charge of copper is given, which is 2. So we just write it Cu2 plus. And then the oxide ion, which is O2 minus. Good. So what are the valencies? The valencies are 2, 2. Interestingly, there are equal number of negative and positives. We have positive 2, we have negative 2. So these ones, they can just cancel out for us to get our neutral compound. And so our compound is going to be CuO. In this case, we don't have to write Cu subscript 2 O subscript 2 because the negatives and the positives are cancelling. We didn't do anything to that. They are just cancelling out. So we don't have to touch anything there. Now the C is capital, the U is small, and then O is a capital. So we have our chemical formula beautifully written there. Another example is aluminium trioxonitrate 5. In this case, we have a radical there, but still with the steps, we are going to write the compound into ions, the cation first and then the anion. So aluminium, Al3 plus, and then the nitrate ion. So this is where you should have many examples of the radicals. You should have a lot of them. So NO3 superscript -1. So we write their valencies, which is 3 and then 1. We give the valency of aluminium to that of the nitrates. We give that of nitrate to aluminium. This means that we are going to need 3 of the nitrate ions because each one will carry a charge of -1. So the 3 of them, we are going to have -3. And that of the aluminium, which carries a charge of 3 plus or +3, would now balance for us to get a neutral compound. Now, this is a radical. NO3 minus is a radical. And radical means they have come together. So everything is for all of them. So the 3 that we are going to give is not going to be for nitrogen alone or oxygen alone. So the best thing to do for the 3 to affect all of them when writing it as a subscript is to indicate it in a bracket, is to put the radical in a bracket and then the 3 outside the bracket as a subscript. So what we have written there indicates that we have 3 of the nitrogen atoms, and then we have 9 of the oxygen, and aluminium is outside. What is outside is multiplying the whole of what is inside. Alright, so this is going to give us a nice compound, which is our aluminium trioxonitrate 5. Another example is sodium trioxonitrate 5. Now in this case, once again, there is a radical, but we still have to write into the cations and the anions. We have the sodium ion and then we have the nitrate ion. So the valencies, we have 1 for them. Straight away they will balance each other, so we don't need to do any multiplication here. Since they are cancelling out, we don't have to put the radical in a bracket because we have just 1. So our formula now becomes NaNO subscript 3. The O is capital. Take note, if with the radical we have just 1 of it, we don't put in a bracket. Unless we have more than 1, then we can put in a bracket and write the number as a subscript. My good friends, this is where we end this session, and I'm leaving you with these questions. Try your hands on them. My name is Robert Chumesi Kuma. Thank you very much.